Hello there. Welcome to this video. In this video, we are going to make our first discrete event simulation of a simple queuing system using the QPython package. Now I'm going to read a little blurb that comes right out of the Q official documentation. It's just the most basic starting example, and we're going to go through it together. So actually let me share it right onto my screen so that you can read along with me. Okay, assume you are a bank manager and you would like to know how long customers wait in your bank. Customers arrive randomly, roughly 12 per hour, regardless of the time of day. Service time is random, but on average lasts roughly 10 minutes. The bank is open for 24 hours a day, 7 days a week, and has 3 servers who are always on duty. I hope that they're robots and not people. If all servers are busy, newly arriving customers form a queue and wait for service. On average, how long do the customers wait? Okay, so to get started here, we have to make some clarifying assumptions. You can see in the example below, as we'll type out in just a moment, that they make some interpretations of what at random, when they say customers arrive randomly, okay, but in this case, not uniformly randomly for how they interpret the question. In this question, they assume that there are exponential distributions for both the arrival distribution, that's the inter-arrival times of new customers, and the service distributions, which is the amount of time it takes to complete a service. So let's get started with a Python file, and we'll call this, I don't know, super creative here. We'll call it tutorial 1. And we'll follow along with their code. So the first thing, we're using the Q package. We're going to import the Q library. Now, there's 3 key pieces of information to make this example work. We're going to call this network, and we're going to create a network with some stuff in it. But what stuff do we need? The first thing, usually in order of the arguments that the package expects, though you can change the order of positional arguments in Python if you wish. But we need to define what the distributions are. So here we'll go q.dists and choose the exponential distribution with a rate parameter equal to 0.2. And recall with the exponential distribution, or if you're new to the exponential distribution, that the average is actually 1 over the rate. And so if this is 1 over 5 for the rate, then the average is going to be 5 over 1, or 5. So then we'll have a service distribution, which is also going to be, in this example, an exponential random variable. So here we'll say that the rate is equal to, in this example, 0.1, and that matches with their description of saying roughly every 10 minutes, because the average is going to be 1 over 10. Okay, so that's it for the arrival distributions. And then the last piece of information we need here is the number of servers, which in this example we're going to assume is a constant value of 3 throughout the simulation. Now, this definition, oh, and by the way, there's, in my particular editor with my type checker, it's complaining that it can't find what's inside of dists, but it does exist, and I'm not worried about that. And you don't need to be worried about that for this video. So the next thing is, this is a definition of a queuing model, but it's not the same thing as a simulation, and it doesn't have any control over the randomness, as it were, or the pseudo randomness. Now, actually, I'm going to put the seed up here, and just for, well, I could use the same seed. Why not? We're setting a seed here, and that controls the pseudo random number generators that are used for these exponential distributions. It can make it reproducible, but you may want to try different seeds to make sure that your results are stable in general. But let's not get too far ahead of ourselves. We want to make our first simulation and get it up and running. So we can create a new simulation instance by calling the simulation constructor here, and we will pass in our network class, or our instance of a network in Q. Now with that, we're actually ready to create a actual simulation run. So what this is doing, this q.simulation, is it's defining some additional data structures for how to put the simulation together and some things about how to run the simulation. But this is still not actually running the simulation. So to run the simulation, we have to pick one of the various simulation methods. We could simulate until deadlock, or until a maximum number of customers have either entered into the network or have exited the network, or the maximum amount of time that we have set for whatever reason we care about, maybe the length of a planning period. And that will run the simulation until that much time in the simulated time has elapsed. And in terms of the units of time, you have to make choices. Like here, this is 1,440 minutes, but that's only because the way we set up our other parameters are also correspondingly on a scale of minutes. Okay, so to verify that our simulation is working, we can run this tutorial file and we don't get an error, so it works. And I think that it's very tempting at this point to start digging into the simulation results, but I think that will be an upcoming video. So if you've been following along, thank you for watching. Congratulations on making your first simulation in the Q Python package, and I will see you in the next one.